For the second part of the lecture, we are going to talk about the Parquet file. Up to now, what we have been mainly doing is what you have been doing most of the time would be to work with a CSV file, which is a basic, simple text tables where each row is written out line by line. That's basically what it is in a CSV. But given that you're doing a course in data analytics, you need to understand that data sets grow in millions or even billions of rows sometimes. Okay. And CSV, in context where you have rows which are in millions and even billions of rows, you will see that CSV start to show its weaknesses. So normally, when you are dealing with a large data set, let's suppose I talk about the census data. Maybe, for example, it might be more efficient to save it as a Parquet file rather than saving it as a CSV file and working with the CSV file for analysis purposes. So it's CSV basically it's big, slow to load, and doesn't remember the data types properly. What do I mean by that? I'll talk about that in any case later on. So what I want to do today is to introduce to you the concept of Pocket. I've already been mentioning it last week in my previous video, but I'll formally touch on that today. And normally, the Pocket file is a modern file format that is designed for large scale analytics, as you would realize. It's used heavily in big data systems, generally things like Spark, Hadoop, and even cloud platforms. As I said to you, it is mainly used to deal with large data. If you're dealing with a small data, maybe you might not see the purpose of using it, but it becomes really, really efficient and useful when you're dealing with big data. That's one other thing. What is the difference between the Parquet file? What's the difference between a Parquet file? You will see that normally Parquet, not what is the difference between a Parquet and a CSV file? You will see that the CSV file is row based. What does it mean by it is row based? It means that it stores each row completely. All right. So data are read according to rows. On the other hand, when we talk about Parquet files, it is column based as you are seeing here. I've already posted this interactive display on Google Classroom. You may have access to it whenever you want to better understand what is in there. So the main difference is that one is row based, one is column based. Now, what does this mean normally? What is the advantage of the Parquet pertaining to the fact that it is column based rather than row based? The advantage now, when you look at it, you won't see much of a difference. You just see a data table like that, which is arranged in rows and columns. But you will say, what's the difference? There is not much difference, obviously, when you look at it as it is right now. But the way the data is stored makes the whole difference. Because when you are going to fetch data or to query and to search or filter data, let's suppose by region north, if you are using a CSV file, searching for north would imply going through product um, 101 to north to 1500, and then as you are seeing the highlight going and do the same thing again and again everywhere. So the searching for a region called north, if you want for example to count how many north you have, it will need to go row by row as you are observing in this display here, row by row, to be able to determine how many north you've got. So in other words, it had to go through 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 records, for example, in this particular example here. 15 records just to be able to determine how many nodes you got. On the other hand, the advantage with the Parquet, on the other hand, is that given that data is stored in columns, you will see that uh, if you want to find out how many nodes you have, you just need to get the data from only that column here, which is region. You don't need to go through all of these rows one by one. You just need to scan one, two, three, four, five data points to be able to determine how many north you got, for example. That's just an analogy between CSV. Now imagine here you have to go through how many you have to go through 5 times 3, 15 data points just to be able to determine how many north you've got. Here you have to go through only 5 data points to determine how many north you got, for example, or if you want to filter by region north. So the thing here is that you won't see the advantage in terms when data is small, because when the data is small, this would be as efficient as it is here for region. It won't make much difference. It is going to be in milliseconds difference, maybe. I don't know, but it's not going to make any difference as such. But imagine dealing with a data set with billions of rows and many, many columns. Suppose 1 billion rows and many, many columns. Suppose 5 columns. So basically, you have 5 billion of 5 billions of data points that your data needs to go through, compared to if you were using a Pocket file, you will just need to go through 1 billion data points. So that's a little bit the main difference. So this means what, in other words? It means that a Pocket file will normally give you smaller file size. That's one. It will give you faster reads. That's two. And it normally you can load only the columns or row you need instead of the whole file. I leave it to you to go through this interactive display to see the advantages and disadvantages. I've already been mentioning some of these. Like, you have faster queries, you have a very good and perfect compression of the data, very good compression of the data, not necessarily perfect, but then you have also um, data types which are stored compared to a plain CSV file. Normally, when you are saving a CSV file, if you have a one column like in a CSV file, like you have this column is product ID, and this column is north, and this column is sales 1500. The CSV does not know what a region is, what sales is in terms of data type. The CSV basically just considers everything as a simple text. That's all it does in a nutshell. But it doesn't know that this is, for example, a categorical data. This it doesn't know that it is, for example, quantitative data, and so on and so on. Uh, I mean, for the CSV, it doesn't know that. But in a Pocket file, things are different. The data type is already stored. Uh, the data, the Pocket file already knows that CSV is supposed, not CSV, but sales is supposed to be quantitative. It should be an integer, for example, and it saves it as a schema. All right, we will refer to that schema later, and basically the advantage is that it stores the data types. It's not like a CSV, which does not have any necessarily data types. There are so many other things that you can go through, that you will read. Of course, there is a disadvantage with this Pocket file, is that it is not so human readable. All right, as you will see, you will need to for the Pocket file, you will need to use a package in R, for example, called Arrow, that will enable you to read the Pocket file. You can't just read it as it is. Like a CSV, it's very easy. You can just get your CSV, open it, and see what's going on there. But it's not the same for a Pocket file, because it's a binary data. So if when I refer to binary data, it's machine um, language, and it's not readable by a person. So what are we going to do now? So we are going to see the differences of a CSV um, and that of a Pocket in R. Let's start by opening R, obviously, and I will use a tiny example to show something to you. All right, but bear in mind that this tiny example is not sufficient. I will also give you an example which is from a bigger file in a moment so that you understand how one loads faster than the other. As I remind you, for those who are not really used to this software R, I would highly encourage you to go in the materials that I gave you to learn and study R on your own because you might be into some trouble if you throughout the whole course if you are not enough conversant with R. Let's get started with that particular small example that I mentioned. So I will start with a tiny small data set of just 10 rows and I'll save it as both CSV and Pocket file. Okay. And then I will show you how we can apply filtering and so on in that. So to start with, let's load our libraries that we need before we move further. We have our library arrow that we are going to use to be able to write a Pocket file or read a Pocket file, obviously. But I'm going to show you in a moment where this is used later. And then you have a library deployer. This library deployer is especially uh, useful, I mean, when you are dealing with pipes, when you are dealing with pipe syntax. Okay, what do I mean by pipe syntax? These are the kind of things that you deal with sometimes that we call pipe syntax. You have things like filter and you have things like collect. All these are part of the deployer package that we can use. Filter, collect, and the pipe syntax are part of the deployer package. And we are going to use all these, by the way, today. That's why I've already loaded it once and for all. But there is something that you need to bear in mind here is that if in case you don't have these, if in case you don't have these already installed on your laptop, the first step would be to install the packages using the name arrow. I already have it, but again, just like I did for the first video, I will do it together with you just for the sake of completion. I will do that as it is here, so that you can also follow with me what's going on. So before you are able to load these two libraries, your first steps would be to install the packages. All right, remember last time I also did see I installed several packages at once. You could also do that instead of having it on two different lines. So I click on OK for cloud. I'll just wait until it is installed. As you would have observed, I've skipped the installation because it takes some time. So these are the kind of messages that you'll get, maybe a bit different for you. Then when you have done the installation, what you need to do is to put it as a command so that you don't run that code if you do Control A and running all your code at once. So you avoid running the install packages again because you've already downloaded it. So there's no need for you to do to download it again and again. So you only thing that you need to do is to do the library arrow, library deployer, and so on. All right, that's basically what you want to do normally. So let's load these two libraries because I've already got them installed. The next step is to create a small data set. I'm just going to say small um, example. All right, I've called it example as exp, doesn't matter. And then I say data frame. Remember, in a data frame in R, A data frame represents a list of different variables in column form, for example, and these variables may be of different types. We will start by an ID column where I'm going to include 1 to 10. What am I trying to do in this data frame? I'm trying to collect data. I'm trying to write some data pertaining to bus routes and boardings. How many people have boarded um, a bus from Port Louis to Cupid, for example, Port Louis to Rosehill, and so on. That's what I want to do. So to be able to do that, I will give my second column the name root, and this name root will contain different um, roots. What are the different roots? I've just noted it here so that I don't take too long. Just make review. I'm just copying and pasting that here. So let's put this down there for the frame. And here we go. This is what we have. We have PL QPIP. This is the first data for Port Louis QPIP, and so on. That's what we have. The next step is to, um, having done so, let me just remove that here. We need to write down the boardings. How many people have boarded these different routes? Again, see between bracket, I will just copy and paste the values that I have. Here we go. So we have a boardings, which is given like here. So what is it about? When I created data frame, I will have a first column called ID, and there will be ID 1 up to 10. The second column will be called root, and root, the first ID would be PLQP, Port Louis QP, and the second will be Port Louis Rosehill, and so on. Then you will see that for Port Louis to QP, there are 35 people who have boarded this route. Now, when I say ID is equal to 1, it depends. It may be related to a particular day of the week, a particular day of whatever it could be. I don't know. I'm just taking an example like that. So it could be anything. In fact, it could be uh, at a particular time in the afternoon of a day or things like that. uh, and you will have probably more data, but here I'm just taking only these as example. To facilitate reading, I'll just put this here so that you can understand what's going on. So the route is here, you have the boardings which is here. The next step is to run that. Let me run that. So just before I run it, I need to remove that as a hashtag. I don't know why I put that there. Uh, I remove the hashtag, and I just check if everything is working properly. Seems like yes. And then I can run the whole thing, and then I'll see if it works. Yeah, if it works perfectly well, you can now view your small expenditure. Small expenditure, excuse me. You can view your small example, and the small example is given here in the form of a data frame. Now, what do we want to do? For example, want to um, save this file, number one, as a CSV file in my folder somewhere, and I want to save that file. So I've got a folder here. You will see the path here, which is here, Parquet, and so on. I want to save it in that folder, and then I will also save it as a Parquet file. Not only as a CSV file, I'm going to save that same data as a Parquet file. So how am I going to do that saving of the same data as a Pocket file? To be able, not Pocket file, to start with, let's talk about the CSV version. To save it as a CSV file, I need to use the function write.csv. And in write.csv, I will need to call the name of the data frame that I have and put it here. And then I say, where do you want this data to be exported? And under what name shall it be exported? That's the other thing that we want. To be able to know where it should be exported, obviously I need to come to my folder as it is here, for example, and then I click on that taskbar here. When I click on the taskbar, I get the address. And when I get the address here, I can minimize that for a moment. And then here I can put in between inverted commas the address that I have obtained, bearing in mind that I need to change backward to forward and just check if there is no backward, which means something before. So the fact that there is no backward slash before in this code, I'm going just to run it here itself. I replace all the backward by forward. It's not over. You need to give it a name. You can give it a name. For example, I may call it small example. Let's call it small exp itself. And then I need to give it a name called CSV. I mean extension. Now, this is okay. The other thing is that to avoid having this 1, 2, 3, 4, 5, 6 up to 10 appearing again, I just put another argument to that function, which is row.names is equal to false. All right, row.name is equal to false. I can execute that and see what's going to happen in the file. So just remember the file was empty. I'm going to run that code here and I move to my file. I'm supposed to have my data appearing in a moment. You can refresh it if you want. And then the data has appeared. You've got the write.csv. Okay, normally you should not have a .parquet. I guess it was somewhere there earlier. Just give me a second review. This was not there normally. Let me just delete that and let me just delete that and run it again. And then we do a refresh. There we go. We got only our small example CSV. You can open it if you want. You will see that it will give you the different routes information, port list to queue, etc., etc. So that's part of it done, but we have to go through a second part, which is to write this file as a packet. That is, you save that data that you have, which is in column form, the data frame, I mean, you are going to export it as a C as a packet file. That's what I want to do now. How am I going to do that in a packet file? Number one, I will need to come here at the end. I will say the same thing, right? But instead of saying .csv, I will say underscore parquet. And underscore parquet, of course, I put the name again and I put the same thing, the same address again, as you will see here. Same thing. So, but of course, I will not call it a small example.csv, but I will call it parquet. I'm going to run that. Remember that there was non-parquet here. So I'm going to run the last bit here and then we'll see what happened. You will see that normally a parquet file has appeared here. Let's have a look at it quickly. When you have obtained your Pocket file, what you want to do, probably one of your how do we say, one of your instinct would be to open that file as it is here. Let's try to open that and you will see what's going to happen. This is going to be only gibberish. There is nothing useful that you would be able to extract from easily. Let me just show you what happened. You will see here the example of when I try to open that, what I get. It's not really a good thing to keep because normally, remember that Pocket files store data in binary format. So you won't need to open it like that. You will need to use arrow to open that data. So, having done that, our next step would be to read the file, these two files. We have learned how to create the two files, but we can now read these two files. How do I read these two files? Let me just put something down there. I call it CSV all. When I put read.csv, this function is used to read a file. But before I will do that, maybe what I will do to make things a little bit easier is I'm going to set what we call the working directory. The working directory is this, obviously. Come here, I put it there between inverted comma. That will make things a bit easier. You will see what I mean by that in a moment. Each time of copying and pasting this, you will make things far easier. Let's change that and put it as set working directory. This, in other words, indicates that your data and everything that you're going to fetch would be from that particular directory, which is going to be Pocket file. So now I can read my CSV all. I do read.csv and I put the name of the file that I have decided to save. You will remember that it was called small exp.csv. So I put this here, and of course I will need to put it in between inverted comma. Now that this is done, we can run these two uh, immediately and just check what we have here, the CSV hole. You can also, if you want, view the file, and then you will see that it has loaded the file correctly with the ID, root, boarding, and so on. Okay, so having said so, now we can move on to our next part, which is basically to determine to uh, to to rather create a subset of the CSV that I've worked with, to create a subset of that CSV, where I'm interested not in the whole thing, but I'm interested in only port risk QPIP. All right. So that's what I want to do now, is to create a subset of that file that I've saved, a subset of that CSV file that I've saved, where I'm interested in only the port risk data, that is the port risk QPIP data 35 and 31 and so on. So basically to do that, I can just give it a name, CSV underscore PL underscore Cupid. Just note something. Please don't put that minus or whatever here. That would not work in a naming. When you're naming something, you don't put a minus there. All right. Note something also, that this here, the names are, the formatting of this name is not a minus. Look at the difference between a minus and that. This is a hyphen that has been worked on Word, and I've been pasting that directly here. So this is why you have to be careful. If you wrongly call the name of port Louis QPIP later by putting PL minus, you will be in, you will not be, it won't be correct. Okay. So what do we want to do? We are going to do CSVPL QPIP, and then we do subset. And subset means, obviously, it takes only part of a CSV that we have created here. And what do we want to subset it by? We want to obviously subset it by the root of port Louis QPPL CP, which is 35 and so on. So what do? We come here and then we say root equal to. Now I will explain to you what I just did in a moment. So Instead of copying and putting minus, I would rather copy that PLCP and place it here. Okay, so just to ensure that I don't get a mistake later. By the way, you would have noted that I've put two equal signs. It's very important that you understand that one equal, if I say that, if I say root is equal to PLCP, it would mean that I'm assigning PLCP to root. But here, I'm not doing an assignment. I'm basically doing a comparison of root with regards to PLCP. So, in other words, I'm telling how to go and find all roots that are equal to PLCP. I'm not saying to how to replace all root by PLCP. If I do that, I'm basically asking how to replace all roots by PLCP. This is why you have to be careful. This is a comparison operator that we call that. So we can run that now, and we can also obviously have a look at it to see the difference. Here we go, we run it, and you will see that there is only a subset of that data that has been selected. So what we just did here is that we are filtering. Now note something, you load everything first here, load everything first here, and here you will be filtering after reading. You will do the filter after reading. Normally, as I said to you in my previous example earlier, that does not make much difference in such type of data because the data is relatively small. But it matters a lot when it comes to a really huge data where you are dealing with millions and billions of rows. Going through that process, you will see, takes a huge amount of time. This is why we need to learn the Parquet, how to read a Parquet file, how to open the Parquet file, how to read it, and so on. That's what we want to do next. So we'll get into the filtering of the Pocket file now. I'm going to explain to you how to do the filtering of the Pocket file, but just remember something. With the Pocket file, the port list QPIP uh, has been filtered after having read the file. But the advantage that we have with Parquet is that I can put that filter into the file read itself. Why? So that it brings back the port list QPIP rows in the first place itself. So I don't need to load and then filter, but the filtering is done at the reading stage itself. So let's get into this and explain to you how we can do the filter and what's the difference, so that you understand the difference between these two. So first of all, let me call it a name DS, all right, and then to be able to filter the port list QPIP using Parquet, I will need to use a function called open dataset. And of course, I need to put down the name of the Pocket file that I've been working with. You remember the name of the Pocket file. Don't forget the extension as well, please. That's very important. The extension small exp. So I need to put the name of the Pocket file that I've saved, right? So we are reading the file from what I've saved earlier. You remember here, this is what I have here. This is a Pocket file that I'm referring to. So you will see that I'm reading it directly. By writing this open data set here, it's very important that you understand something. Is that I'm not reading the file. This does not, this does not load the data into memory. That part here does not load the data into memory. It's what we are doing by writing this function of open data set is that it just creates a pointer. A pointer is like a connection, and it is creating a connection to that Parquet file as I've shown you earlier. It's just creating a Parquet file, a connection to that Parquet file. Think of it like opening a book on the right page, but not reading the whole text. Okay, that's a little bit what it is about. Now, if you when you are done with that, you can, if you wish, you can run that. I will show you. I just confirm that. Let me run this first, and then you will see that it gives you information about the file, like you have three columns and so on, but it does not at any point in time load the data. It's just creating the connection, and that's basically all right, that's what it is. So to be able to move forward with the filtering, I can use now that ds, that connection that I've done. I can use that and do the filtering. All right. Um, how am I going to do that? You remember I call it CSV PLCP. So I'm just going to change it to PQ PLCP, and I will use that DS file, that DS connection, that DS connection. Through that, using that connection, I will use something that we call a pipe operator. All right, I will use something that we call a pipe operator. What is this? Let me just write it down first of all. This is what we call a pipe operator in R. Now, the principle of the pipe syntax, what does it mean? It means that it takes the result from the left hand side, that is, it takes the result that you have from the left hand side, that is the connection that you had, and then it will pass it on as the first argument to the function that you will have on the right. That's what it is about. What is the function that I have on the right? The function is to do the filter. I will show you, I'm showing you that, but there is another way of writing it down, obviously. And you are going to pass a filter that you are used to, the same function that you know, filter, and then you will need to not filter, but the same thing like subset, I mean, excuse me. You will be using the same principle. The filter here is a bit like the subset that you are doing up there. So you use that uh, function of filter to do that subsetting here. But it's not over. I will need to do something else. Now, this filter, you will see that it is done during the file read. It is done during the file read, all right, because the filter is pushed down to the file scan itself. That's what it is going on. What is going on here? So it's not like in the previous case where you read and then you filter, but this time you are filtering it at the reading stage. There is a difference as you would observe here. Now, remember, the pipe operator make things a lot easier for you generally to write down functions. Okay, it makes things far easier to write down functions. It makes it natural. It's a very natural way of writing things down. But I'm not yet over. When I've done the filter, I need to go one step ahead, where now I need to collect the data. I need to collect the data. What does this mean by collect? Let me just write the filter first. I'll need to collect the data. Now, this part of collect is when the file is actually read into the R memory. So far, as long as I don't use that function collect, the data in is not read into the our memory. It's only read at this stage. So you will see the difference. Before you read the file, it is loaded in the data, then you filter, but this time the collect is where the file is read in the R memory. What file? The file that contains that filter. So in other words, basically the filtering is being done at the collection, if you want it, at this stage rather. So what did we just do here? We started with DS, that is the dataset pointer to the Parquet file. We filter, and then this can be if you want, and then, okay, translate it to and then if you wish. All right. And then we filtered all the root of Portwist to QPIP, and then we collected the results into our memory as a data frame. That's basically what we have been doing in this small example. Another way of writing it down without the pipe syntax or the pipe operator would have been, for example, something like that. Collect, but it makes it a little bit less friendly to read. All right. Filter and then ds and then the root equal to PLCP. That's the alternative version of the same thing, if you wish. All right, the same code without this pipe looks something like this. Okay, but with the pipe um, syntax, the pipe operator, it makes things a little bit natural. Like for example, here you say you, you create the connection and then you filter and then you collect. That's all. So that's why you can use a pipe. Sometimes you can use it, sometimes you may not use it. It's up to you which you prefer, depending on the context. All right. Now, this done, just remember something. I want just to come back to that. What is happening here is that instead of reading your 10 rows in the filter, instead of reading your 10 rows, then discarding 6 rows, arrow, your package arrow that we had earlier, is only reading 4 rows from that disk. All right, it is in the first place itself, it's only reading 4 rows. It's not reading all the 10 rows or whatever it is. All right, that's what it is doing. It only takes at the reading stage, it only takes what is required. It doesn't read the whole thing. You're just building a query plan basically that says, uh, for when I'm reading the file, just take the rows where the root is PLCP. That's basically what it is. Very simple, in fact. The filter instruction normally get passed to the Parquet engine that we refer to as arrow. Now, for the collection, I already mentioned that. We can just execute that and see what's going on. We can run that single file here, and you see that you got a table of 4 by 3. A table is a modern version of a data set, of a data, not data set, sorry, of a data frame. If you can consider it as a modern version of a data frame, there are some advantages that you have with a table that a data frame won't have. For example, just printing the characters, just not the characters, but the data types just below the variables is something that a table gives compared to a data frame, which doesn't normally necessarily give that when you run a data frame. But anyway, I'm not going to get into the details of what a table is, but just for information, a table is just basically similar to a data frame, but a little bit a modern version, if you wish. The what we have just done in this exercise here is that we have created a file. We've saved it as a CSV, and we've saved a file, our file as a Parquet as well. And when we've saved the file as a Parquet and a CSV, it is important to note that, let me open that. If you want to open the CSV, you can open it without any problem. It will open. All right, just give it some second. By the time it opens, uh, let's wait a minute before it opens. Anyway, you can see it already in the preview here that it is appearing in the preview. But it's not the same for Parquet file. All right, let me just quickly open that. In the CSV, you will see that, here we go. You will see that the file is here, but there is a small error of with regards to the formatting. As you would see here, you would need to be careful when you are saving, especially when you have the formatting issue. What happened is that when I was copying the port, Louis PLs, etc., I was copying it from Word and and made a mistake. So normally you have to be careful with these kinds of formatting. This is the hyphen, but at least you can open the file without any problem, and it works perfectly well. But when it comes to reading the Parquet file, you will see that if you try to open that Parquet file and try to open it, for example, in Notepad, let's suppose, just once, if you want to open it in Notepad, that's the kind of thing that you get. That's the kind of thing that you get. All right. So you can't read a Parquet file directly as you would read for a CSV, obviously. This is why you need the package that I've explained to you, the Arrow package, to be able to load and read a Parquet file. So just a quick recap. What we've done here is that we have been learning how to create the CSV, how to create a Parquet file and saved it as a Parquet and so on. We've also understood how to do a filtering of a particular route in those two data, and the filtering of this two routes in these two data was done, one using subset for the case of a CSV, and was done one using filter for the case of Parquet. But more interestingly, you had to, if you want to open a file in Parquet, you need to first of all establish the connection using open data set. And when you have established the connection, then you can do whatever you want with that. You can do your filtering, you can collect the old data, and so on. Now what I want to do next is to show you the advantage really of using Parquet. So far, you did not see the advantage except in theory, as you just heard me explaining it to you right now. But what about the practical side? When I told you that the filtering is done at the reading stage in Parquet, compared to CSV where you read and then you filter, the difference comes in the speed at which these two files are going to execute. All right, that's basically the difference. The difference is just in the execution, how much time it takes to execute a CSV and how much time it takes to execute a Parquet. That's mainly the difference that you're going to see. So for that, we can't use that small data set to show this difference, but we'll take a different version of that data set. I'm going to use a different version of that data set, which is a bit a bigger data set to show you that. Just before I get into this bigger example, if you want to get the old data set without the filter, you can easily do that. All right, one pipe, that is, you collect the data. So remember that you have to collect first to be able to see the result. Here we go. Let me just check that. Here we go. You will see that you get the old data set. So if you want to do the filter, you can do the filter and then you collect. That's all fine. It's up to you. Okay. So let's get into the bigger data set now. I'll just close the R and open a new one. I'm using a relatively similar example. All right. I've already posted the data set on Google Classroom, a relatively similar example, just a few additional things like, for example, you will have the stops and also the route, all right, and the date as well, but the route mainly has changed. I made it simpler. We have red, blue, and so on instead of all these other dates, all these port lists and so on. I made it simpler just to avoid having these formatting issues and so on. So what happened now? I'm going to use that data. I've saved it in my in my folder somewhere. I saved it in my folder, and for you, you already have it on Google Classroom. Let me just show you. You will have it there under bus big data sets. You will have these two. Just when you're going to download these two, when you look at their file size, you will see the difference already in these two. Just bear in mind that these two data sets contain the same content, but when you look at the file size, you will see how much they are different at all. So what I will do, just to be a bit faster, I'm just going to copy and paste my path. First of all, let me load the library that I need to work with. As usual, I will work with library arrow and also deployer full pipe written now. Then I've got my two paths that I've already copied and pasted here. Obviously, you will not have the same path. Just bear in mind, these two data set, you will save it. For me, I'm calling it bus big CSV path, bus big packet path. Your link will be different from mine, obviously, but do not forget you need to have your file name at the end. If you're trying this at home, ensure that your file name is well mentioned at the end. Normally, it's called bus big. If you did not rename it or anything, you will see that it is busbig.csv and it is busbig.parquet. If this is not working, it means that you probably, if after doing that, when you load the data later, it doesn't work, it means that probably you wrongly saved your file, or you have something saved like twice and you got something like that. Okay, you got it saved twice, and then when you saved it in your folder, excuse me, when you saved it in your folder, you are getting something like that, and you forgot to put the bracket one. So be careful in how you save your file. Ensure that the path is not the same as mine. I repeat, your path is going to be different because it depends on where you have saved that file. Okay, so let me just remove that, and let me remove that as well. Having done that, now what I want to do to start with, let me get some information about my files. What are their size? Okay, what are the size of these files? I've got two files here. I will just copy and paste these two files path here, and then I will put that in a vector because these are the two file paths that I have. And then what I want to do is to get some information about these two file paths. So I file.info. Information will basically give me quite a number of information that you can have, but I'm interested in mainly their size. Okay, so this is why I will put $size. You can just play with it to see the file info later and see what it contains, and I will give it a name if you want, or I can just run it like that. It's gonna be okay. I can just run it like this, and we run all these first, and then I run the file info, and we'll see that because I put the big CSV path first and the big Parquet path second, obviously that size is rated to the big CSV and that size is rated to the bigger, to the Parquet file. You will see already here that we are dealing in the millions of bytes. So 5 million bytes. Here you are not dealing in 5 million bytes, but you are dealing with 744,000 bytes. There is a huge difference between the file size of the Parquet and the file size of the uh, CSV. You see that it is 6.7 times. It takes far more space in your computer. The CSV file takes far more space in the computer compared to the Pocket file, 6 times more in this particular example. It's not always necessarily that it's going to be always 6 times more, but in that particular example, it's this case. So you can already see how much it is bigger in size compared the CSV compared to the Parquet. So we already see an advantage of a Parquet right from the start here in terms of the compression ability of the Parquet file over the CSV file. It takes less space in your memory of your computer in your storage space. Now, let's move on. The other thing I want to show you is the speed at which these files are read. Okay, the speed at which we read these files. So, what is the speed at which we read? Let me think about what. Yes, let me just get directly into that. So we want to read the file. We've got first of all the read.csv function, which is a usual function, and we got the read underscore parquet, of course, under the arrow uh, package, read underscore parquet. So we have these two, read.csv, we have their path that is given here. We are just going to copy and paste that, and there this path as well, and put it there. So we've got these two read.csvs. Obviously, I will give them a name. But before I give them a name, what is more important is rather to put to get information in terms of how much times it takes for reading the CSV file on my computer and how much time it takes for reading the Pocket file on my computer. To be able to get that information, we can use a function called system time in R. And system time give me information related to these to how long it takes for reading this file. And then I can run these two things and you will see the amount of time it took. For example, for reading, we will focus mainly on the elapsed, normally the elapsed time. You will see that it took about 0.19 second compared to 0.06 second to read the file. So for CSV, it took longer, and for the Parquet, it took far less time. Now, you just just note something. We are dealing in with the data. Let me just show you the dimension. But before I get into the dimension, maybe I will give it a name. Let me just call bus big underscore CSV. And then I call read.csv. Where is it? Yes. Let me just run that here, give it a name. I will tell you something. I will tell you what is the dimension of this. So we are dealing here with a data set of 120,000 rows and 5 columns. That's what we are dealing with right now. Okay. Uh, so you need to understand that we are dealing with a relatively big file. Imagine you are dealing with a file that contains millions of rows and even billions of rows when you're doing data analytics, as I mentioned to you. You're dealing with big amount of number of rows. So what would happen then? You can imagine how long it will take for reading a file compared to reading it from a Parquet. That's one thing that is important to do. All right. Now, the other thing, let me just give a name for the Parquet as well because I might be using that later since I'm here. For reading the Parquet, by the way, you will use a read underscore Parquet as I mentioned here. And this is going to read the full size, all right, of the Parquet. So when you get there, you can view your um, big CSV if you wish, and you can also view the Parquet file. And you will see I'm not doing any filtering here for the time being. I'm reading the whole thing. So you can do it using that function read underscore Parquet. You will see that they are basically the same files. They are the same thing. There's no difference between these two. All right. So let me run this one as well, and we can see them both together next to each other. You will see that the big Parquet file and the big CSV file, they are basically the same. There is not any difference between these two. Basically, they are the same file. It's just the format that is different, as you would have noted. If you go and scroll down, you will get the same amount of rows, same number of rows. So there's not much difference, just to confirm that, okay? So remember that if you try to open the big Parquet from your node, this big Parquet file from, that is the bus big Pocket file that you have downloaded from Google Classroom, you will not be able to open it. The only way to open it would be through using this function, for example. That's what will enable you to download and open it. So I've shown you that. Now we can move on to the filtering process. I've been explaining to you earlier. I'm not going to go through that again. So let me just say CSV. I want to filter only the blue routes. All right. Instead of taking all the different routes, I'm interested in only the blue routes. I want to do a filtering on this blue route. I can use subset as I mentioned to you, and then I will need to do it on the bus big CSV. All right. And then I'm interested in the route which is blue. I'm again not explaining these because I've already explained it to you earlier what all these different information, so you can just rewind and check. So, but the only thing that I did not explain here, I stopped here last in the previous example, but now I'm not interested in all these different information that you have in the data file. If you type str, let me just do that quickly. Um, bus big CSV. If I type str plus big CSV, you will see that there is date, there is route, there is stop, there is boarding, there is ID. Let's suppose I'm not interested in any of these, even the stop or anything. I'm interested in, let's suppose, only boarding and route. Oh, if I'm interested in only route and stop, I can do that. Okay, I can do that. How do I do that? I come here and I do an additional argument to that function that we will call select equal to C, and then you put the name of the variables that you want to keep. For example, let's suppose in my context I want to keep something similar to what I've done in the previous example. I will do that, and this is going to be my subset, and then I can view it. And let's run that. Sorry, let's run first there and then run this one, and then you will see only the blue has been selected as you are seeing here. All right, we have 60,000 rows of blue that has been selected, the blue route. Okay, now we can do something similar now for the parquet as we've been explaining. Let's call it DS again. Open, as you would recall, open data set. And in the open data set, you have to be careful. You cannot, in this particular context, put the bus big parquet. You would rather put the path, as you would recall earlier. Don't put the file name here. This is a bit different from this one. I can do the subset with the file itself, but I can, if I want to filter for using open data set, I will need to put the path, not the data that has already been loaded in the memory. That is not the big bus bucket, but rather the path where it is. If I want to filter using the same method that I did earlier. Okay. Now, when you establish the connection with the file, the next step is to do a selection of the blue. Let's call it PQ blue. And as you would recall, we will use a piping operator, the pipe operator. Sorry, I have a tendency to say piping, but the pipe operator rather. You would use a pipe operator, and from the pipe operator, I will use another one, so I'll just copy and paste that here. So the pipe operator, and I will do filter as I did earlier, and I will put the root equal to blue, as you will see here, but it's not over. I've got an additional thing to do. As you would see that I also need to select route and boarding. That's something that I did not explain to you earlier. So from I establish a connection, and then I filter, and then I select the route boarding, and then I will do the collection. That is, I will read the file now in in R. Okay, so I need to close this bracket because it was through the field. Let me just check that. Yeah, so select. That's okay. Excuse me. Here we go. Run that route. Donc, let me just confirm what's going on. The issue is with this here. Normally, you don't need to put the C root boarding here in the piping operator. Let me just run this first and then run this one, and it works well. So you would recall that if I run the S, you won't get the data, but the metadata, rather, information about the data. And then if you want to view the PQ underscore blue, you can just check it out quickly, and then you will see that you have the roots and the boarding. Very easy, very nice. You don't have the row names and anything. So you have here the row dot names, root, like in this case here you have row dot names. I told you earlier that the data is a table, and it's a kind of modern data frame, and it is even better to go through the PQ. You will see that using this format, the table made data frame ensures that things like row names does not appear in the data. So that's one thing. But now what is more important is to conclude on that part. What is more important is to check the read time and the system time, how long it takes to read the file. So I will just copy that again and paste it down there, and I will put that in this function of system.time. You would recall that was what we wanted to do, by the way, earlier. Will recall that's what we wanted to do earlier. So we want to ensure that we want to check, rather, if really the Parquet file, when it is filtering, it does it faster than the CSV file. That was to check the advantage. So what I will do, I want to run this part here. This is equivalent to what I've run above there, I mean. So what I want to do here is to put that in between system.time, and of course close this bracket here. But just be careful. I can't read the file from bus big CSV because it's already in the RAM right now. It's already in memory. So if you read it normally, it is expected that if you run that as it is right now, what is going to happen? You will see that CSV reads faster than Parquet. It's not correct because you are using what is already in the RAM. So it's what if you really want to make something comparable, you need to go and use a read.csv path that you had earlier. Okay, you need to go and use a read.csv path that you had earlier. That was uh, big bus. Sorry, that was bus big CSV path. All right, that was what you had earlier. So you're gonna use this read.csv bus big path as I told you earlier. Do not, please, read it directly from read. Do not use the how do we call that here? Do not use the big bus CSV directly. All right, this is an object that has already been saved in R, and it if you read it that if you do subset from it, it will be in the RAM and it will be fast. So you do the subset from as if you are starting from scratch reading the file. All right, then you can make a comparison, then you will do the root and so on. Let me run that. I hope what I'm saying is right. Let's check this for a moment. Let's check that quickly. You see, here we go. Using CSV, it took 0.33 seconds to do the filtering because it loads the data. After loading the data, then it will do the filtering. But using Parquet, it took only 0.01. You see now the big advantage of the Parquet file. So to sum up, we've been able to to check the advantages of using the Parquet. We've been able to write a Parquet file. If you have a CSV file, you want to write it in Parquet to save space on your computer, you can easily do that. But ensure that you always you always use the arrow package that is available so that you can read the CSV file, the Parquet file. Just bear in mind that if you have CSV files that are very big, you can easily compress it using the Parquet format, but you need to have a means of reading it because you can't read it directly. So you will need to read it using these different methods that I've explained to you. All right, and you will need to use the arrow to be able to do that. That's all for Parquet. Another video will follow for an introduction to SQL. Thank you for your attention. See you. Bye.